Moving into chapter 3, we're going to start looking at linear systems. And a system of equations is a set of two or more equations containing two or more variables. A linear system is a system of equations that contain only linear equations. So for example 1, we'll have to use substitution to determine if the given ordered pair is an element of the solution set for the system of equation. So in other words, does that ordered pair work in both of the equations in our system? So just to refresh your memory, an ordered pair is in the form x is the first number and then y is your second number. So if I plug that in the first equation, we're going to have, let's bring this down here, we're going to have 2 minus 2 times 4 is equal to negative 6. So this would simplify down to 2 minus 8 equals negative 6, and 2 minus 8 is negative 6. So it works in the first equation, so that's good. And then we have to test out the second equation. So 2 times x would be 2, plus y would be 4, and they're saying this should equal 8. So simplify. 4 plus 4 equals 8. That is true as well. So if they're both true, then our answer is yes, that ordered pair is a solution to the system that was given. So for one more example here, we're given the ordered pair 3, 2, and the system 2x plus 3y equals 12 and 8x minus 6y equals 24. So go ahead and try them out. The first one would be 2 times 3 plus 3 times 2. They're saying we should get 12. So that's 6, that's 6. 6 plus 6 is 12. So yes, it works there. For the second equation, we have 8 times 3 minus 6 times 2. And they're saying we should have 24. So 24 minus 12 is supposed to equal 24, but 24 minus 12 is really 12, not equal to 24. So no, this doesn't work in that equation. So no, this is not a solution to this system. It has to work in both equations. So for your assignment today, this is what you're going to be looking at. Just this part. They're going to be giving you an ordered pair. You plug them in to see if it works. The rest of the week is broken up with the rest of what we're going to talk about in these notes. So there won't be no new videos after today, but you will have an assignment on these other parts later on. So example 2, it says use a graph and a table to solve each system. So to use a graph, we have to take each equation and we have to solve them for y. So if this is x plus y equals 4, we're going to have to minus x to solve for y. So the x's would cancel and we would have y equals, and we can't do 4 minus x, so we just write 4 minus x. And then for the other one, I'll just use it right here. We have to solve for y, so I'm going to minus 4 from both sides, and we're going to have 2y equals x minus 4. And then I have to divide both sides by 2, so I have y equals. Now for this side, we just have x, we don't have a number in front of it, so you have to pretend there's a 1 there, and we have to do 1 divided by 2, which is just a fraction, 1/2, and keep your x. And then we have to do this negative 4 divided by 2, which would be negative 2. So both things have to get divided there. Now, in order to graph both of these, I'm going to graph this one first here. And our y-intercept is that positive 4, so I'm going to put a dot at positive 4. And then our slope is the number in front of x, and that's minus x right now, so that's minus 1. So our slope is negative 1, so that means I can go down 1 over 1. And what I'm going to do is I'm going to go down 1 over 1 a few times here, just because I can't draw a straight line perfectly. So we want to try and get all of the points that fit on the graph taken care of there. So that is our y equals 4 minus x. Then for this one, our y-intercept is that -2, so a dot goes at -2 on the y-axis. And then our slope is 1/2, so that means up 1 over 2. So up 1 over 2, there's a dot. And I'm going to continue this, up 1 over 2, up 1 over 2. And then I can draw my line there. So our answer is, where do these two lines cross? And the answer to that is at 4, 0. So we're looking for an ordered pair. Now it says use a graph and a table. Graphing is much simpler, but if you had to use a table, you're going to have to pick points to plug in. So you're going to have to make a t-table for both equations and plug in x values. So for instance, in this first one, 1/2 x minus 2, if I plugged 0 in there, I would have to do 1/2 times 0, which is 0, minus 2 is -2. And then for the other one, we would have 4 minus 0, and that would be 4. So those aren't close together, so then I have to pick another value. 1/2 times 1 is 1/2, and 1/2 minus 2 would be -1.5. And then 1 in the other one would be 4 minus 1, that's 3. So a little bit closer together, but still not where we need to be. So we need to continue on with this until we figure out where they're the exact same. Well, we already figured that out in the graph. So if I plugged 4 in for x, 1/2 of 4 is 2, and then 2 minus 2 would be 0. And then if I plugged it in the other one, I would have 4 minus 4, which is 0 as well. So then you can see they match at 4, 0, which was our answer. So I suggest using the graphs. I think it's quicker and easier, but totally up to you which way you want to go. All right, a few vocab words here. A consistent system is a set of equations or inequalities that has at least one solution. So that means it could have more, but it has to have at least one. An inconsistent system is one that doesn't have any solutions. So what that means is the lines don't cross. So those are going to be parallel lines. Because remember, our solution is where do the two lines cross? An independent system is an equation with different slopes. So that means they have one equation or one answer. They're only going to cross in one spot. And then a dependent has equations with equal slopes and equal y-intercepts. So those are the same line. So they may look different, but if you were to graph them, they'd be the exact same line or same equation. Okay. So for pictures, if we had a system that only had one solution, it would look something like this, where they cross in one spot only, and that would be consistent because it has at least one. So consistent, and independent because they have different slopes. The lines are not tilted at the exact same slope. And then infinitely many solutions is our other option. And the graph would look something like this. Even though there's two equations given, it's going to be one line because they're the exact same line. And if we were to classify that, we would say it's a consistent system because it has at least one. Well, these have all the points. They cross at every single point. So it has infinitely many solutions of where they cross, infinitely many points. So consistent. And then dependent where it says they're the same line. So they have the same slope and same y-intercept. And I just realized this should say independent, not dependent. And then no solution is our third type. And if two equations have no solutions, that means they don't cross. So they're going to be parallel lines. And those are going to be called an inconsistent system, where there's no solution. So example 3, we have to classify. So in order to classify, we need to solve for y. So this first equation, I would have to minus 2x. So I would have y equals 3 minus 2x. Over here, to solve for y, I'm going to have to minus 9. And then I'm going to have to divide by a negative 3. So 6 divided by negative 3 would be negative 2 with the x, and negative 9 divided by 3, negative 3, would be a positive 3, and that would leave me with y. So if you notice, this is a minus 2x over here, and this is a minus 2x. This 3 is positive, and so is this 3. Now, they're not written in the same order, but they are the exact same equations. So that means they have infinitely many solutions because they are the same line, same equation. So infinitely many solutions. And then our classification would be consistent and dependent. So a lot of words there for that answer. And then last one, we're going to have to do the same thing. So we have 3x plus y equals 3. And we're going to have to minus 3x. So we have y equals 3 minus 3x. And then on this one, we're going to have to minus a 2. So we would have y equals negative 3x minus 2. So now let's compare. Our slopes, they're both negative 3. So those are the same. So same slopes, but different y-intercepts. So that means that if we go up here, dependent says has equal slopes and equal y-intercepts. That is not the case. This has equal slopes, but different y-intercepts. So it's not dependent. So it's not infinitely many solutions. And independent is an equation that has different slopes. So it's not independent. So it doesn't have one solution. Inconsistent is a set of equations or inequalities that has no solution, that is parallel. And if you remember from last chapter, we talked about parallel lines have the same slope. So that's what these two lines have. They have the same slope. So that means they're going to be parallel. And if they're parallel, they're never going to cross. So this would be no solution. And inconsistent would be the classification.